Hello, good evening. Hello, good evening. Grace Tabel,
Evening.
how are you? Please, what journey class no work on down can talk about Bianchi this. All right, all right. So today, you see, the MA class, almost still multiplication, no more. I'm enjoying you. My means skipping multiplication. So now let's talk about the transpose of a matrix. So when then can simply means say when transposing a matrix, it is written in the form of this. It is written in the form of this. So meaning that if it is B, if it is matrix B, then you are transposing to the B which the power T. So what it simply means is when transposing a matrix, rows will become columns. So we know normally it is row times column. All right. Let's say row is 3. Then column, when transposing a matrix, it will now turn into 2, 3. The row will now become 2, and then the column will now become 3. So basically that's it. So if let's say we have 1, 4, 7, 6, 2, 2. If let's say we have this matrix. What type of matrix is this? What type of matrix is this?
Unless you share the screen, I can't see anything.
Livy, you can't see. First time, are you seeing my screen?
I can see now. I can see now.
Ah, okay. So what type of matrix is this?
Go ahead. 2, 3.
Okay, 2, 3. So we have yes, steady. It's not a 2, 3 matrix. It's not a 2 by 3 matrix.
Is that?
It's not a 2 by 3 matrix.
This is 3 by 2. Sorry.
So we have 3 rows. And then 2 columns. But if you want to transpose this, it will now turn into 2 rows and then 1 column. Say 1 column. 3 columns. So 3 columns. So what it simply means is here will now be written like this: 1, 7, 2, and then here will also be written like this: 4, 6. 462. Let me share whiteboard instead.
Hold on. Give me 2 minutes.
Let me share whiteboard instead.
Finally, someone has joined.
So we didn't see the person. Okay, so now let's continue. So let's say if we have a matrix of, let's say, 1, 3, 4, 1. Please, what type of matrix is this?
2 by 2.
2 by 2, so 2 rows, 2 columns. So if we want to, let's say we name this as matrix A,
Mhm.
and we want to transpose.
A.
How then do we do it?
I'm coming. Transpose. Refill.
Refi. So I
Aye.
in the transposition, so here is row times column, right? This is the original.
Yeah.
This is the original listing. So 2 rows, 2 columns. So in transposition, we will now still be having 2 rows, 2 columns. But whatever is on the row will come to the column. Whatever is on the column will go to row. So now this is on the column. 1 and 4 is on the column, right? Right, to come to the row. 1, 4,
That's will be 1, 4, 3, 1.
3, 1.
Okay.
Dear, are you getting it? Are you getting it?
Yeah. Yeah, I'm getting it.
Okay. So let me bring in another one again. So let's say we have 6, 2, 7, 4, 3, 3, 1, 2, 6, 4, 6, 6. So yes, interesting. Please, can somebody help me transpose this?
You're coming. Hold on. Very well.
1 minute. I'm giving you 1 minute. 1 minute. So basically, we have
So the transpose of A is 6, 3,
6,
6.
Sister.
6.
Okay, and then
2, 3, 4.
okay.
And 7, 1, 6. And 4,
And then 4.
4, 2, 6.
All right. So basically, this it. You've been able to transpose. This is simple.
Yes.
So even in real life, you see when a girl and a guy are there, they can transpose themselves. So the same thing. And Monte say, okay, yeah, me treat you. Okay, so let me go back to the slide. So basically, that's what it means here. But the way they've done it here, no, you will be confused. So I'm moving on to the identity matrix. So an identity matrix, which is denoted by the sign I, is a square matrix of dimension n times n. So meaning that it is the same. So it can be a 4x4 matrix, a 2x2 matrix, a 1x1 matrix. Like it is the same number of rows and the same number of columns. That's what they mean here. Where all elements on the diagonal are ones and all other elements are zeros. So what they basically mean is that here, 1 is supposed to be here. And then this will be 0, 0, 0. So the diagonal here are ones. And then the rest are zeros, as you can see from here. So basically that's what they mean. So we can also get this as an identity matrix. 0, 1, 0, 0, 1. You see diagonal. So we can also have these two as a matrix. 1, 0, 0, 0, 1, 0, 0, 0, 1. This is also an identity matrix. So what it basically means that this identity matrix, when multiplied by any matrix, you get the same matrix. So if let's say we have something like this. So if let's say we have something like, want to at least finish this identity today. So if let's say we have 1, 4, 6, 1, 2, 1, 1, 1. If you solve it and then you multiply it by this identity matrix, 1, 0, 0, 0, 1, 0, 0, 0, 1. You are going to get the same, you are going to get this same thing as your answer. So that's what basically it means. So let me show this, let me quickly ask this question. In real numbers, if in matrices, this is the identity, this is how the identity look like, or this is the identity. In real numbers, who can give me or who can tell me what the identity is when it comes to real numbers? Anybody? So if basically identity is the number that when any matrix is multiplied by it, you get the same matrix. in real numbers too, what number that when you multiply to another number, you get that same number. So in real numbers, we can say that 1 is an identity, because even if it's 6 billion, if 60 times 1 is the same, is 600 times 1 is the same 600. So any number times 1 is the same number. That's the same thing here when we are dealing with identity. So the identity multiplied by any matrix is the same matrix distance. So if A, and then this identity is denoted by I. So if this matrix is multiplying this identity, you will still get the same A. That's what it means. So at least we will have some more time. So, do you guys suggest I teach how to add, subtract, and multiply matrices with calculator right now?
Yes, do it.
All right. So let me quickly come into the class. Few minutes.
Progress.
Still Motimenka. Can you guys hear me? Okay.
Yeah.
All right. So if let's say this is the calculator, can you see it? Can you see the calculator screen?
Yes.
Okay. So if you want to do a matrix question, click on mode. Then you see option 6, which is the matrix. You see there.
Yes.
Then you click 6, and then you click on mat A, which is matrix A, which is 1. You see 1. So you enter 1, and then you choose the type of matrix, whether it's 1/2 matrix or any of them. So if it's 1, fine. If it is 3/3 matrix, you choose 1. If it is 3/1 matrix, you choose 3. Any of them, then you. So let's say we are going by a 3/3 matrix. So we choose 1, and then we enter in the figures of matrix A, right? So let's say if matrix A is 1, then we use the direction to the second side. Sorry, 1. We type 1, then equal to. Need to move to the other side, then 2 equal to. Third side 3 equal to 4, 5, 6, 7, 8, 9. So I've entered all the coordinates in the matrix A. So now what I need to do is now press shift and then 4. which is matrix, shift 4. So shift and then 4. Then I go to data. You see, one is dim, second is data. So I choose 2 data. And then I've already added matrix A. So I'm not coming to add matrix B. So I come to 2, which is matrix B, 2. Then I choose whether it's a 2 by 2 or 2. Let's say it's also 3 by 3 matrix, so still 1. So we still press 1 again. And then you also insert that one. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm still doing the same thing again. So I've re-entered another one at matrix D. So now what I need to do is to press the AC key, which is what we normally use to put the calculator off. So I press the AC key. Then I press mode again. Press mode again. Now I've inserted the values for the matrices. I've inserted the variables for the matrices. So now I press mode again. And then 6. Then I choose matrix A. No, it didn't save. Okay, I'm coming. 1, 2, 3.
So guys, so actually I showed you that we are right here with 1,000 Ghana. Then we are going to Takuma.
Oh, I'm coming.
Everybody around. I told you the thing that we have this you're invited.
So now I press, after inserting everything in the same process, the one that we did, I press shift and then 4 again. So now I see matrix 3 and matrix A and matrix B in here. So I choose option 3, which is matrix A. So I choose, so matrix A will come. So meaning that the coefficient of whatever I place in matrix A is inside here, but they will not show me. So now I press either plus or times. So matrix A plus. The same shift and then 4 again. Then I choose option 4, which is matrix B. Then I press equal to, then it gives me the answer. So the mean, the first one is 2, 4, 6, 8, 10, 12, 14, 16, 18. So this is how you add it. This is how it to be added. So you just press shift and then choose matrix A and then plus matrix B. Then you are good to go. So if you want to multiply it, so you go back and then, because you've already keyed in the informations already, unless it's another question or another input, then you insert it again. But since I'm still doing it with the old one, I come to shift again and then matrix, which is 4, shift and then 4. Then I choose matrix A, which is 3 here, times shift for option 4, which is matrix B, as you can see here. And I press 1 equal to sign. So different figures again. So all the assignments I gave you the last time, you can simply use calculator to do it. But if I teach you the calculator way, You won't go in the long way. That's why I didn't do that day. Do we understand this?
And please, can you go over it again? I wasn't here at the beginning.
Okay. I'm coming. Let me reflect. If I didn't be here. So what I mean is, if you want to solve matrices problems using the calculator, all you need to do is to click on mode. Once the calculator is on, click on mode and then choose option 6, which is matrix. Option 6. Then you choose 1, meaning that you are putting the figures in matrix A. That is 1. So you choose 1. Then if matrix A is a 3 by 3, 3 by 2, any of the matrices, then you select. So here it is, let's say I'm using a 3 by 3 matrix, so I choose 1. And then now I input the figures of the matrix A. So let's say it's 1. You press the figure, then you give an equal to sign to move you to the next part of the matrix. So 1, I press equal to sign, then move me to the second side. So 2 equal to sign again, 3 equal to sign, 4, 5, 6, 7, 8, 9. So you see, I have inserted everything in here. Then I press shift. I press shift and then 4. After inserting, I press shift and then 4, so that I'll be able to insert the coefficient for the matrix B. So shift and then 4. Then I choose data, which is the option 2 here. So I press 2. And then 2 again, which is the matrix B. So I press 2 again, which is B. Then if it is a 1 by 1 or whatever, so I'm using a 3 by 3 matrix. So I'll choose 3 by 3, which is option 1 here. And then I insert the figures again. 1, I'm also using the same 1, 2, 3, 4, 5. So 1 equal to sign 2, equal to 3, equal to 4, equal to 5, equal to 6, equal to 7, equal to 8, equal to 9. So now everything is done deal here. So I've inserted both for matrix A and B. So what I need to do is just to press the AC sign, right? So that the information will be stored. So the AC sign, rest, everything is clear there. So you'll be thinking it is not clear, it has been stored. So now I want to perform my operation. So what I have to do is press shift and then 4 again to send me to the matrix interface unit. So it has sent me there. So now I need the information of matrix A, so I press 3. So information of matrix A is in here. So I want to add it, or I want to do addition. So I want to add matrix A to matrix B. So matrix A plus the same plus, then shift 4 again. Then I select 2, 4, which is the matrix B. You see, 4, which is the matrix B. So 4. So now I press equal to, we will say is equal to. So I press the equal to sign, and then you see that everything has been solved. Simple and you can see here, right? So if in case I want to multiply, I press the AC sign again to go to 4. So I press shift and then 4 again, and then I choose matrix A, which is 3, and then times shift and then 4 again, and I choose 4, which is matrix B, right? Then I press the equal to sign again. Everything is done there. Everything is done there. Do we get it?
Yes.
Do we get it? Or hello, is there any question?
No.
Yeah, I understand.
Okay, please. Everyone understands. But
Yeah.
Everyone understands, right?
Yes.
So after today, we can transpose matrix and then also solve addition and multiplication problems using calculator, right?
Yes.
So tomorrow we will have another class, and then we'll talk about the inverse of matrices, and then now we'll go. Okay, Monday then we'll start linear programming. All right. So basically, in the absence of any question, then we will close for today. Is there any question like pata?
There is concerning to the assignment you gave, you see there was 3 by 1 and this one 2 by 1. So with that one, how are you to multiply that one?
Hello.
Yeah. What was the question you said again? Maybe I can help. Say it again and let me see.
I wasn't the one that asked the question.
I wasn't looking for the girl.
I'm sure she's talking about this one, question 2 and question 7. Yeah, I'm sure.
Question 2 and question 7.
Yeah, I'm sure that's the question that she wanted to ask.
Sure. I think question 2 and question 7. She wanted the solution or what?
I'm sure.
The
person that asked the question, she's missing. Can't ask the question.
But you do understand it.
Yeah.
Okay. I don't know why Nehemiah is muted.
Don't mind him.
Maybe the question has gone.
Do you know, sir? I didn't know I was muted. Oh,
Wow, see.
When
So you were talking all this while.
I was talking anyhow. Man.
So sad.
You can put them some more day, Jamie.
Kafla.
To mute me one casa there, 5 million.
And a kafra.
Nana kafra. I'll send a recording. Well, I'm just a calculator with a bit map for the send a recording that everything can be changed.
Okay. Obi bisa question 2 ni question 7 ni way of your open solution but nipa no ye hu nipa no.
Alpha calculator ni. So some baby some message I'm gonna send you.
Okay.
Class the main tomorrow.
Okay.